Okay, we're ready to start our webinar. Welcome to the joint webinar with Siemens and Prolim. Today's presenters are Emmett Thelman from Siemens and Mike Hunter from Prolim. Now, questions will be answered live at the end, but feel free to put them in the chat during the presentation. Mike, the tech talk is now yours. It's leveraging engineering data for smart quality manufacturing.
Thank you, Vicki, and welcome everybody. We appreciate you attending this morning and taking the time. We're excited to share some interesting ideas with you. Before we jump into it, I want to just go over the agenda, what we're going to try to get done today. We'll start out with an introduction of Prolim and who we are and who I am, and also with Siemens, and some background on the Siemens portfolio from Emmett. Emmett's going to take us through some global trends that are driving smart manufacturing adoption. We want to talk about leveraging design data on the production factory floor. And then we want to get into how we use that data with our 4 pillars of smart manufacturing. And from Prolim's perspective, that's advanced planning and scheduling, manufacturing execution, IT/OT convergence, and enterprise data optimization. And then, as Vicki mentioned, we'll have some time for questions and answers at the end of the session. And as she said, please feel free to pop them into the chat as they come to you, and we'll get to as many as we can. So let's jump into it. My name is Mike Hunter. I'm an account executive with Prolim Digital Manufacturing Solutions. I've been in the Siemens ecosystem for the better part of the last 10 years. Started my career in manufacturing in a heavy equipment and aerospace manufacturing environment. I've also got a lot of experience in prime labels and packaging. I've been on the operations side for multiple label manufacturers. As far as consulting and software sales, I've worked for Siemens directly as an enterprise account executive. I've also worked for channel partners like Prolim, and I've got a lot of experience selling manufacturing solutions in injection molding, roll goods, whether it be paper, film, nonwoven fabrics, or metals, heavy equipment manufacturers, and food and beverage. So a little bit about Prolim. We just celebrated our 20th anniversary. We have 12 locations around the world and over 600 employees, over 1,600 customers. We are a Siemens Platinum Smart Expert partner in the United States, India, and Asia Pacific regions. We are also an AWS Advanced Manufacturing and Industrial Services partner, as well as a Microsoft Azure Solutions partner. We're also a Snowflake Enterprise Data Analytics and AI platform partner. So from a practice perspective, we have a large footprint with Siemens Teamcenter, hundreds of customers in the United States and around the world. We also work with Siemens SimCenter, OpCenter, and Industrial Edge products. As I mentioned, we provide cloud services through AWS and Azure, be that managed services or infrastructure consulting. We also provide process consulting and implementation. So we provide implementation services for all the software that we sell. And we have an IT staffing division as well for our customers who have large projects, maybe don't want to hire people permanently, but are looking to fill temporary or temp to perm positions. We'll go out and find the right resources for them. Again, we have a global presence, multiple locations in the US, India, Australia, New Zealand, Canada, and Germany. So that's a little bit about us before we jump into the content, and I'm going to pass it over to Emmett.
Yep. Thanks, Mike. You can progress to the next slide. There you go. So my name's Emmett. I'm the Director of North American Channel Sales here at Siemens. I've been with the company for about 10 years, and really my role and my group's role is to help partners like Prolim in introducing Siemens technology and helping us solve our customers' challenges. So Siemens is a very large organization, as you know. I'm not sure what everyone's interaction is, but we're a very large corporation. I think we've got about 7 different divisions, everything from PLC sales, motion control, to software, which is where we're really talking about today. But we have a lot of the same challenges as our customers. Being this large company with siloed divisions, we lack really sometimes even a cohesive vision and strategy, but communication as well. And we're seeing that with our customers and their kind of how they are meeting the challenges today and trying to really combine large organizations together or different divisions like manufacturing, engineering, into one cohesive group. And that's what we're doing today with Siemens. We've got this strategy, our purpose of one tech company, to bring over or together the different divisions for a single strategy to combine the real and digital worlds, and really want to have a large customer impact and really bring different technologies together so that we can have a bigger effect at our customers. So once we've built this foundation, and I came to Siemens through an acquisition where we're constantly acquiring companies, I think about $20 billion worth of companies over the past 15, 20 years. And we really want to build this leading position in industrial software and factory automation and bring these services to our customers. We've come across the same trend that you guys are seeing, I'm sure, with AI. We've really built a large workforce to try to bring this technology to our customers, and we're really trying to align our portfolio to some of the larger global mega trends that we're seeing, which is what I'm going to get into a little bit more in the future and now. So it's a real pivotal moment for Siemens and our customers, right? Markets are changing, our competitors are moving very fast, and technology, especially with AI and other things, are developing at a real rapid speed. So I'm going to go through some of these trends now and kind of their implications and what we're seeing. As you're looking at maybe our technology, you should be, have a good understanding of the trends that we see and the implications for the market and what we're doing to our portfolio or with our portfolio to help our customers meet those trends. So the first and the biggest is globalization. Really, the changes in global markets and the political conditions that are putting a lot of pressure on manufacturing companies and even Siemens, right? We are a manufacturing company as well. So some of these implications are relocating production between regions. I see this all the time when I'm talking to my customers, where they have global locations, but they're all different silos, little fiefdoms that people have created. They're not on the same software. They're not on the same file structure even sometimes. They can't manage data. And really being able to relocate between different regions, being able to spread manufacturing around as needed is something that's really pushing a lot of our customers. And overcapacity in certain markets is really one of those trends as well. Add new products to existing plants. I live in Michigan, and I just saw a news article about a plant for General Motors in Lake Orion, very close to where I live. This was touted as a huge EV plant in Lake Orion, but now with some of the changing conditions, EVs are not as much of a hot topic. They're shifting that existing plant from EV now back to ICE engines. So companies have to be very quick to change as markets are changing. And then different products in multiple plants as well. Another trend we see is time to market, the constant need to introduce the newest, most innovative features to meet customer demand. We've seen this for a very long time. It's nothing new. But I think with the current age and AI and all the different sort of trends we're seeing out there, time to market is really getting condensed. Customers are expecting products to get to market really fast, and management is expecting that as well. So shorter planning and design cycles. I've seen this a lot with our customers as well, where manufacturing really needs to start much earlier in the process, right? Everything's shifting left. Oh, got a little bit of feedback. Everything is shifting left in the process. So we're really trying to reduce production ramp up and leverage existing assets. Going again back to that example I've seen at my customers, where they're between sites, between divisions, there's no communication. They're maybe not even using the same CAD system. They can't leverage existing assets. Same with manufacturing. So this is something that our customers we see are trying to change, and we need to support them with our portfolio. Another trend is environmental sustainability, right? And this is both for product and production processes. So we're seeing this a lot, initiatives from the top down, and we're seeing this from product design transformation, supply chain transformation, material transformation. There's a lot of different impacts to this trend. So people are looking at their supply chain, they're looking at operational efficiency and process innovation. So sustainability isn't just the product, but it's also the manufacturer or the manufacturing space. How much energy is your machines taking up, right? How much are they using through their production process? And then product design and transformation, as I mentioned. So this all kind of comes together in one of this mega trends, if you want to call it, of smart manufacturing, right? We've seen technology increasing. We've seen this really on the production silo where technology has increased, right? We have cloud computing. A lot of our customers are starting to put PLM, CAD into the cloud, right? And that's really lowered the burden, the cost, not just in the cost of software, but the cost of IT, in-house IT, to bring product enhancements that companies like Siemens are coming up with to really move product design to be much faster. And this has now gone into manufacturing. So we're seeing a lot of these trends pushing towards a new business model, operational efficiency, which brings along things like cybersecurity, cloud, right? Virtualization. And again, that's where Siemens can really help. So our value proposition is really in our digital manufacturing portfolio of products. We really want to improve collaboration, efficiency, ensure quality and compliance, and really increase speed. So we've created a large portfolio of products in our digital manufacturing portfolio that can help with everything from planning, production, simulating production, the actual execution, logistics, down to service, and even service lifecycle management. So we've built through these acquisitions that I mentioned earlier, this really large portfolio of products that can help our customers bring smart manufacturing, all these technologies that have been really in the production silo over to the manufacturing silo, and help our customers kind of take that next step to smart manufacturing. And that goes down to kind of that key strategy of Siemens as a one tech company, that we really want to combine the real and the digital world and help our customers do that.
Thanks, Emmett. Appreciate the insights, and those are certainly issues that we see with all the manufacturing companies that we talk to. And next thing I'd like to do is give you maybe a really tangible example of the change in manufacturing environment and customer habits and expectations. So I grew up in Huntington Beach, California, and I want to tell you a specific story about the difference between how we interacted with brands when I was a kid and how things are happening today. So I'm guessing most of the people on the call have heard of Vans. Vans is a global brand in skating, surfing, lifestyle shoes. But that wasn't always the case. Vans was founded in Anaheim, California, about 15 miles away from where I grew up in 1966. It was a small family-owned business. And when I was in fifth grade, if you didn't have a pair of Vans, you were probably not a very significant fifth grader. It was a big deal in Orange County for sure. And I remember one day in 1980, my grandmother took me to the Vans store, which was right down the street from her house. And they had a sign on the counter that said, "Order your custom-made Vans here." And I walked up to the counter, and they had a pile of papers that had been photocopied sitting there. And there was a drawing of a shoe. And you wrote down your name and your phone number and your shoe size. And you selected everything that you wanted on that shoe, different colors, different patterns, how you wanted it made. And they were going to make that pair of shoes especially for you. Now, I thought this was the coolest thing in the world in 1980. And I was pretty sure that if I was to get these custom Vans, which to my knowledge, none of my friends knew about, this was a brand new thing, that I would probably not only be the most important fifth grader in my school, but probably in the world. So I was very excited about this. I filled out the form, I handed it in, gave the guy a deposit. He said, "Yeah, your shoes are going to be ready in about 6 weeks." I said, "Okay, great." So every week I thought about my shoes, and we were getting closer and closer. When 4 weeks came, I asked my mom if I could call. She said, "No, 6 weeks, you should wait." So the sixth week came, I called and said, "Hey, can I come pick up my shoes?" They said, "Well, actually, we had some problems in production, so your shoes aren't ready yet. Call back next week." So I called back next week. Now we're at 7. No shoes, call back next week. Called back the 8th week, no shoes. Call back the 9th week. Finally, "Yeah, your shoes are ready. Come down and get them." I went down, I picked up the shoes, paid for them, took them home, opened up the box, went to put them on, but I never put them on because in the time that I had waited, my feet had grown about a size and a half, and they weren't even close to fitting inside that shoe. So very disappointed, but not too upset, because just the whole idea that somebody would make me, a 10-year-old kid, a custom pair of shoes was kind of crazy in the first place. So I was sad, but not surprised. Let's fast forward a few decades. What can you do now? You can go on Nike by You. There are dozens of shoes. You can do anything with those shoes. Any colors, any color laces, any color soles, any color trim, any color main fabrics. There are an insane number of variables. And guess what? You're going to get those shoes in a few weeks and they're still going to fit you. And it's not just Nike that's doing this. Anybody that plays golf out there, you can go on FootJoy and you can get whatever FootJoy shoes you want. And there's our friends at Vans. They've gone and done this probably a lot better in 2025 than they did it in 1980. Converse has the same thing. You might be saying to yourself, Mike, I don't make shoes. I don't have anything to do with shoes. And I looked at the attendee list and I can confirm there's nobody making shoes. But this extends into other industries all over the place. We live in a world where influencers have a lot of power to create their own brands, to create their own models of cosmetics, of beverages, of apparel, all these different things. And immediately they can ramp up demand for those products on TikTok, on Instagram, on Facebook, wherever it may be. And this puts a tremendous amount of pressure on manufacturers. And it's not just the manufacturers of the goods themselves. This ripples through the entire supply chain. Imagine if an influencer wants to come out with a new energy drink and they want to release that to market in 6 to 8 weeks. And there's already documented demand of hundreds of thousands of units. Well, now you've got pressure on the formulation company who's going to get all those ingredients together and actually make the liquid itself. All of their suppliers who supply the ingredients are under pressure to provide those items. You put pressure on an injection molding company who's going to make the bottles that are probably custom designed for that product. You put pressure on a label manufacturer who's going to make the custom labels for that. You put pressure on a machine and line manufacturer who has to build change parts to make sure that you can fill, cap, label, and process those things in a plant. So those things ripple out throughout the industry. And the number one difference here is expectations and experiences. As a 10-year-old kid, I wasn't completely heartbroken because I didn't expect those people to make me those shoes. I thought it was crazy that they might do that. Today, that's not the case. People expect to get what they want, when they want, how they want. And they grew up with Amazon. They grew up with things that we didn't grow up with. So their expectations and how they deal with consumer goods is completely different. And I would even say in a B2B environment, that situation is completely different, because if those buyers are getting younger and they're more used to this kind of an environment, and if you can't provide those things to them the way they expect and in the way that they want it, they're going to go look for somebody else who can. So I think this is a really tangible piece of evidence of how the buyer's journey has changed and how all of us are facing different pressures from our customers. So how do we do this? Let's talk first about how we can leverage PLM and design data on the factory floor. As Emmett mentioned in his opening remarks, traditionally these teams are siloed, the data sets are siloed. And what do we see typically when we go into a company? We see a design team with PDM and PLM data. We see manufacturing engineering driving ERP. We see manufacturing execution producing those parts. And then we see services after the sale. We see traceability of how those products are performing in the market, quality issues and recalls. And we typically see big walls in between all of those teams. So going from what should I build, how should it be built, how was it built, and how is it being maintained, and how is it performing? What we want to do is take those walls down and inspire collaboration between all of those teams, sharing data sets, a single source of truth throughout the process, and having those teams interact with each other more, understanding the challenges that each one of them have as a group and how it affects the overall enterprise. And when we do it right, when we get to a best-in-class environment, we see that collaboration between everything, all the data sets, all the functional areas and functional teams, and we see improved speed to market and improved quality and customer experience. So why is this difficult today? What is it about a typical manufacturing environment that makes this something that people haven't been able to do before? Well, first thing is, typically, the driving data in a manufacturing environment is coming from ERP, MRP. And there are significant limitations in most of those models. At the end of the day, an ERP system is an accounting system. That's what it started out as, and it doesn't matter whether you have SAP or Oracle or Infor or Microsoft or mid-market tools like Epicor or Syspro or Made to Manage. They're all started out as accounting systems, and they grew and tried to be all things to all people. But in the end, they don't have the capabilities that are required to support best-in-class manufacturing. And what do I mean when I say that? They don't understand real capacity constraints. Oftentimes, schedules that are released from MRP are completely unconstrained. They can be backwards scheduled, which is fairly useless to most people on the floor. They don't consider other constraints like operators, required tooling, space constraints. The work orders that are released are limited because they're based on work centers, and we'll get into that more in a little bit. Electronic work instructions, 2D and 3D models showing product requirements, rarely found in ERP systems. And then quality plans and quality requirements are almost never found there. So you have all of these different systems that aren't talking to each other. And ERP is typically the choke point where that data breaks down as we transition it to the manufacturing environment. So let's talk about different data sets that are required for best-in-class performance. I like to think of it as a small, medium, large environment. So if I'm looking at my ERP data set released to the floor, I have a small amount of data. I have a work center, which has a step on a route, which basically tells me I have 5 different mixers in my mixing department. I might have 7 different forming machines in my forming department. I might have 6 different ovens for heat treat. But I don't really know which one I'm going to run them on, and I don't really know the differences between those things because ERP can't model down to the machine level. I have some preliminary material allocations, but if anything changes on the floor, those relationships are typically broken. And I also have some run times and some setup times, but those are not dynamic. Those are static values. They don't really associate the performance to the actual machine or line that I'm going to end up running on. From there, we can go to a medium level of data that we're going to get from APS. It's a lot more granular and a lot more actionable. So now I know exactly when I create an efficient schedule, I know exactly what machine I'm going to run on. And I know exactly how fast that machine runs. I know how long it takes to set that machine up, depending on the sequence of operations. I know exactly what material I should use, whether that's at the vendor level, at the lot level, or even down to the serial number level. I know exactly which operators and which tools are assigned to that machine, and I know if they're available. I can batch orders together if I've got a batch process for ovens or heat treatment or multiple orders running at the same time. And I've also maximized my efficiencies by eliminating waste, eliminating setup time. So now we've got a medium-sized data set. For best-in-class MES, we need a large data set. Each operation needs to be broken down into an electronic procedure with multiple steps. I might have a setup team that has a list of tasks that they have to do to set that machine up. It might have to be signed off on by a supervisor or somebody from QA. I have defined quality requirements and data collection standards. I know exactly what dimensions I need to measure for inbound parts. I know exactly what tests I need to conduct throughout the run. I know how to create a first article inspection and pass that through. I can also look at operator and machine and tooling efficiencies and utilization, and I can enforce the material consumption rules that I've built out in my APS process. So how do we get there? How do we get around this choke point of ERP and tap into other data sets and valuable information that exists somewhere in the organization but isn't currently being shared with production? Well, Emmett mentioned the process of shifting left. And if we look at the different stages of bringing a new product to market, we go from concept, design, plan, validation, build, and launch. And let's start at the engineering release process. If we look at our ability to change over time from concept to launch, it steadily decreases until it becomes much more difficult to change anything that we're doing because parts have been ordered, lines have been configured, schedules have been created and released out to the floor. And so as we see that ability to change, we see the cost of that change rapidly increasing as we get into the engineering release phase. And it also increases our investment along the way. So what if we were to take some of these tasks and shift them left and get more people involved? If we move design for manufacturing, early manufacturing, and detailed planning, evaluation of change impact to the left, we have more ability to make those changes. We can be more agile, and we can reduce the cost of those changes. So specifically, what are we talking about? Why should we manage our manufacturing bombs at this point? We start excuse me, we start with an engineering BOM owned by engineering, where we're defining the product, we're defining the product architecture, but we want to transition that to a manufacturing BOM, and we want to get manufacturing involved in that process early. So why should we do that in PLM? Well, as we said, when we're shifting left, we're integrating more with the design process, lowering costs and investment and increasing our speed to market. We can build BOMs that are showing where used amongst multiple plants, multiple locations. To go back to Emmett's example, we can shift to different locations if we need to. We have improved visibility of that BOM. We can look at cost impact of the BOM. It's also the basis for our bill of process planning process. And when we talk about bill of process, we're starting with products that have EBOMs and MBOMs, and we're looking at different plants and different capabilities in those plants and different tool sets, different operator skill sets, different machine capabilities. And really what we want to do is bring those things together in a more agile environment so we can make decisions at the global product level and the plant level. So similarly, why do we want to manage our routing in PLM? Again, we're integrating with design. We're looking at multiple locations. We're looking at visualization. We're getting more granular as far as sequencing and time and tools required. Our manufacturing cost calculations are more accurate, more actionable. We're creating global electronic work instructions that can be changed and brought up to date in real time. And we're able to simulate and validate all of those processes in the design process. So again, shifting left, getting people involved early. And what we see with best-in-class BOM innovation is 20 times faster performance and visualization. We have single configurations for parts at the plant and sales level. We can quickly make changes across the enterprise and have a unified system to manage our data. So what about quality? Now that we've developed all of these tools, as I mentioned, quality is typically, in the customers that we work with, a siloed system with a siloed team. Their access to engineering data and planning data is limited, as is their access to data out on the floor. So what we want to do is think back to that small, medium, large data set. We want to build a quality plan in our PLM process, and we want to make that plan actionable and closed loop. So as we are taking data from the floor, we're sending it back to the PLM system to see how things are performing on the floor and making sure that we're delivering products as engineered. And if we're not, we can be more collaborative with the engineering department. Maybe there's issues around the manufacturability of that item. Maybe there's issues with certain parts that we're buying from certain vendors. So really, this is how we release data from PLM and quality out to the floor and make it actionable and closed loop. So let's talk about Prolim Smart Manufacturing. We really look at it as 4 main pillars for best-in-class manufacturing. That's going to be planning, execution, IT/OT convergence and connecting, and optimization through manufacturing analytics. And we're going to talk about each of those a little bit as we move forward. So let's talk about scheduling first. You know, traditionally, I think scheduling has gotten less attention than it should. And if you look at traditional thought leadership, you know, there's no Gartner Magic Quadrant for scheduling. There aren't a lot of studies about scheduling. And traditionally, best-in-class manufacturing thought leadership would tell you that, well, the ERP should take care of that. ERP takes care of scheduling. And then we just execute it on the floor. But we know from experience that that's not the case. I've sold and implemented dozens of APS tools for customers that use every ERP you can think of, from Oracle, SAP, Microsoft, Infor, down to the mid-market, even down to QuickBooks, believe it or not, and everywhere in between. And that's because ERP doesn't do a good job of scheduling. And we'll talk a little bit about why that is as we move forward. So there's really 2 aspects to the APS portfolio. There's planning and scheduling. And when we're talking about planning, a lot of our customers will use those words interchangeably, but they mean very specific things to us. So when we talk about a plan, we're looking at a longer term horizon of months, quarters, years, and beyond. So we're looking at forecasts, and we're trying to decide, what should I make? When should I make it? How much and where? And when I make those decisions, what does my overall capacity look like? What do my material requirements look like? And what's the utilization of my current resources? And do I need to make changes to be able to fulfill my demand? When we're talking about scheduling, we're talking about a much shorter horizon. We're talking about what's the best way to execute the plan. And we're not talking about months, quarters, and years. We're talking about shifts, days, and weeks, down to the hour. What is the best way to deal with synchronization in the plant? How do I resolve conflicts and constraints? And how do I make changes when my environment changes? So scheduling is a very difficult problem. For example, if I had one machine with 5 operations, there's 120 different combinations of that sequence. If I just double that to 2 machines with 5 operations each, that rises exponentially to 14,400 different combinations. But in that scenario, we're not considering a lot of things. What if the machines are different? What if they have different setup and runtimes? What if some machines are older and some machines are newer? What if some machines can only do certain types of material or certain widths or certain thicknesses? Do I have qualified operators available to run those machines? Do I have tooling? Do I have any physical space constraints in my environment? Do I have dozens or machines? Do I have thousands of operations? And if the answer is yes, the number of combinations is quickly going to rise up into the hundreds of millions of choices. So when we talk about functionality in APS, really the key is that we can take, ERP, MRP is very good at saying this is what you should do. It's going to give you a list of work orders you should process. It's going to give you a list of purchase orders you should place with your vendors. But it has no idea what you really can do in the real world. So in APS, we manage our primary resources. We can rank machines at the SKU level to know that, if capacity was never an issue, I would always want to run it on line 1. But if I can't do it on time, line 2 is an option, maybe line 4. So we can model those machines at an individual level. We can also batch orders together if we have things like ovens, if we have processes where multiple work orders are going to run together. We can optimize that by grouping them together. And again, we can look at any secondary constraints. Do I have the right operators? Do I have the right tooling? Do I have limitations on physical space in my facility for intermediate goods or raw goods? We can also base this on intermediate good material availability and raw material availability. And we can model dynamic changeover times in the schedule. Some of the benefits that we see when we get to best-in-class APS is 25% improvement in productivity. So we're reducing waiting time. We're synchronizing events across the entire plant through different functional areas. We're also minimizing setup time and waste. We're reducing cycle time by 25% typically because we're making sure that we choose the right equipment for the right operation and the right SKU. We see 50% reductions in raw materials inventory. When the schedule is in constant chaos and you don't have proper tools to manage it, it puts a lot of pressure on procurement to make sure that they're not shutting your lines down. And I started my career in purchasing many, many years ago. And I can tell you that if I had a choice between having twice as much inventory as I should and shutting a line down because I don't have enough because the schedule constantly changes, I'm always going to have more than I should. So that definitely increases your carrying costs and ultimately your profitability. And the last one is we see massive improvements in customer service because now we have a schedule that's accurate and we can quickly and proactively communicate with our customers to make sure that they know exactly when we're going to ship their orders. And it's going to make them a lot happier in the long run. So let's talk about the second pillar, manufacturing execution. OpsCenter X is the tool that we use for MES. It is a SaaS product. It is quick to deploy. It is lightweight. SaaS, as Emmett mentioned earlier, moving to the cloud and moving to SaaS products is happening more and more with customers that we see. There's massive reduction in IT infrastructure. There are reduction in time to market for these services. They're rapidly deployed. Uptime and reliability and security are typically vastly improved when you move to SaaS. Operational efficiencies as well. So OpsCenter X is a fantastic tool. Again, rapid implementation, lightweight solution, very secure, minimizing costs to IT infrastructure, and enabling our customers to take more ownership of the product. So what are some of the things that we do in OpsCenter X? Well, we create a paperless factory floor. No more spreadsheets, no more clipboards, no more entering information after the fact. We're providing data collection for setup times, for run times, material consumption. Again, if we're making rules in APS about what materials should be used for a product, if an operator tries to scan the wrong lot, the wrong serial number, the wrong SKU, it's not going to let you do that. It's not going to let you run orders that are not in the sequence that we've provided for your operators. We have role-based UIs and security access. So We have operator level, we have supervisory, and we also have high level KPIs for leadership. Again, going back to our PLM and quality, we can execute the quality plans and manage non-conformance on the floor as designed and defined in the quality planning process. We have access to 2D and 3D models, and again, rapid integration to APS, PLM, and analytics. Let's talk a little bit about IT/OT convergence, our third pillar of smart manufacturing. Industrial Edge is a product from Siemens that provides integration with lines, machines, PLCs, sensors, and tools. And it is, again, rapidly deployable, and it's a combination of on-prem and cloud technology. So one of the things that we're seeing from our customers today is they are already generating a tremendous amount of data, in many cases, from their PLCs. The problem is it's not actionable. So they're pulling data from tags and from PLCs, and it's telling them things like the temperature 40 times a second. It's telling them speed, is it running, is it not running? But it's not contextualized, and it's not typically meaningful. One of the advantages of Industrial Edge is that we can run Mendix applications in the box. So we can filter data, we can homogenize data, and we can transform it. So we have consistent data sets that we can send to the cloud when we want, how we want. So for example, if I'm concerned about the temperature of a line, I don't care to know what the temperature is multiple times a second. What I care about are limits of that temperature. I want to know if it's trending high, trending low, if it's reaching a threshold that's going to cause problems. And with the Mendix apps that we have, we can, again, standardize that data no matter what PLCs you're running. They could be Siemens, they could be somebody else's. So we're having consistent data transformation and transmission across different sites in your enterprise. And we can set up, we can filter it and only give you the data that you need so it's instantly actionable. In addition, we're contextualizing that with the data sets that we have from APS and MES. So the fourth pillar, and I'm going a little quicker here because I want to make sure we have time to get through all these things. One thing, I want to give you an example of what I mean when I talk about contextualizing data from lines. Years ago, I had a customer who made protein powder. They were a private label supplier, so they made protein powder for people like GNC and Kirkland, and they provided it in large tubs, sachets, pouches. They did all the mixing, and they provided that finished goods packed out for the customers. They had an issue where certain types of powders were getting gummed up and getting wet and they were clogging their filling machines. And so the first thing that they did was, well, it's probably a temperature or a humidity issue. So we need to be monitoring the temperature and relative humidity at the line and in the plant itself to see if we can correlate these quality issues and the clogging of the filling lines with temperature issues. So they did that. And they saw pretty early on that, yeah, when the temperature gets to a certain level and the humidity gets to a certain level, we start to have problems and these lines go down and we can't get product out the door. But it didn't always happen. Sometimes it happened when it got to a certain temperature and humidity, but sometimes it didn't. And they couldn't put their finger on what the issue was. So then they said, okay, well, let's get more data from the floor. Let's get more data from the type of product we're running. Does it happen when we're trying to fill a pouch? Does it happen when we're trying to fill a tub or a plastic container? Does it happen when we're trying to fill a small sachet? And that gave them a little more data, but it was still not really usable, and they still couldn't put their finger on the problem. Ultimately, they integrated their APS system, which had traceability back to all of the ingredients in the powder mix. So it's a fairly simple process. They have a large mixer. They put in anywhere from 6 to 20 ingredients. They mix it, they move it to a filling line, and they fill it and pack it out. What they ultimately found was, through the APS and MES records, there was a single ingredient that appeared in dozens of different SKUs that they produced, and it was bought from 3 different manufacturers. The only time that the line would go down was when this ingredient was in the recipe and when that ingredient came from one of their 3 manufacturers. Once they found that out, they were able to work with the manufacturer around that ingredient and solve the problem. In the shorter term, they just use product from their other suppliers. So this is the power of bringing all of your data together from IT to OT. And it can really improve your process internally and also the performance of your product after it's been sold. So let's talk about the last pillar, optimization and enterprise data through analytics. We've talked a little bit about the full stack. So we've talked about converging IT and OT data. So we've got data from the MES, we've got data from APS, we've got quality data that's being recorded by operators and the QA team as they execute the quality plan on the floor. We're also pulling in data from Industrial Edge. And even after the sale, we can put Industrial Edge devices on the products that are in the field to collect data about how they're performing in the customer's possession. So one of the products, and again, we have a lot of optionality when it comes to analytics, and I'll go through the different approaches that we take depending on, it's not a one size fits all. Some environments are better for customers, some are different. So one of the products we use is Insights Hub. Insights Hub is really a Siemens product that empowers smart manufacturing, bringing together data from assets and operations data to improve decision making. And when we talk about IT and OT, let's look at the IoT. Let's look at the IoT data that we can pull from Industrial Edge. We're monitoring conditions on the floor, energy management. We have anomaly detection. On the mom side of the house, we've got all of that product data from engineering and PLM that we started with. We've got scheduling, we've got material consumption, quality. We know who's running what item on what machine at any given time, and we know that person's level of training and certification. And when we bring all that together, that's when we really see insights that can drive profitability and productivity. And Insights Hub is a great tool to do that. It's an analytics platform that comes with some out-of-the-box applications. It quickly integrates to MES and Industrial Edge. Some of the out-of-the-box tools include predictive maintenance that uses some impressive AI technology. We can also give you OEE out of the box and basic line monitoring out of the box. In addition, you can develop more tools on that platform using Mendix. So what is Mendix? Mendix is a company that Siemens acquired a number of years ago. It is a development platform, really, and it's typically driven by by IT strategy, I should say. So the goals with Mendix are, or the main value proposition of Mendix is to bring applications to users in weeks instead of months or years, which is typically what we see with traditional DevOps, where people are developing things in a traditional way. And with Mendix, we can reduce the burden to the IT team because we can develop these applications so rapidly. And it's really a strategic decision where not only can we can build apps that work on the factory floor, but we can also integrate to any other tools in the stack, whether that's financials, CRM, anything really. There are a lot of pre-built connectors with Mendix, so we can run integrations with Teamcenter, we can run integrations with Op Center, we can look at NX reporting and analytics, we can bring your ERP systems into the picture. And on top of Mendix, Prolim has developed some tools called on our Fascia platform. So we have over 100 Mendix developers, and we've already deployed over 200 solutions. Actually, this slide's a little old. We're closing in on 300 now. And these are really value drivers and accelerators that can take your existing tools, whether they're in Op Center, whether they're in Teamcenter, or whatever CAD software you're using, and bridge the gap between all of them and bring more people together for analytics and workflows dealing with manufacturing, quality, maintenance, HR, people management, inventory and warehouse, and energy applications. So with Mendix, we're really able to offer more flexible solutions that can bring these things together. So Insights Hub is one of the tools that we use. Mendix is another. Again, there's no one size fits all. These are all tools that we deploy in a consultative way, depending on your requirements and your goals overall. As I mentioned earlier on, we're also a Snowflake partner. Snowflake is a data management system that runs on AWS, Google Cloud, and Microsoft Azure. There are tons of pre-built connectors within Snowflake. It uses Mendix as an app development platform. One of the great things about Snowflake is we can build applications using Snowflake's AI, which is extremely powerful. It's an open ecosystem, so Snowflake integrates with all the large language models on the market today. And it's also cloud agnostic. So some of our customers that have a lot of locations and a lot of applications will say, hey, our CRM data is on Azure, our manufacturing data is on AWS. We also have some on-prem data that we manage for quality. We also manage other applications in Google Cloud. But with Snowflake, we don't have to copy those data sets in a multi-cloud environment together to query against them and provide analytics. And we can pull data from all three of the large accelerators, AWS, Azure, and Google. We can pull data from on-prem. We can pull data from Siemens. We can pull data from ERP. And any application that we write will work natively with all of those things. So you don't have to re-engineer the application to say, well, it works on AWS now, but we don't have functionality on Google. We've got to go re-architect it. It automatically works with any multi-cloud deployment. So a lot of exciting things happening with Snowflake. Again, the AI applications are very impressive. We can work with unstructured data, data mesh, data warehousing. We can write with a multitude of programming languages, and we can deploy those across the enterprise for improved analytics. So what does this all mean together? If we take the 4 pillars of smart manufacturing, scheduling, execution, IT, OT, and optimization, and if we integrate those with strong data sources from PLM, from design, from quality, all this together is really producing a true digital twin, taking the digital world and the real world and putting them together, from a digital twin of the product, digital twin of production, to the real product and real production metrics that we get from that manufacturing process. And again, just to ladder back to Emmett's comments at the beginning, if we look at the Siemens accelerator portfolio and some of the other tools that Prolim brings to the table, we're bringing all of these digital twin components together, from mechanical simulation, manufacturing, IoT, and we're designing, we're realizing, and we're optimizing those processes together to bring value to our customers, to obviously put them into position to be more profitable and bring value to theirs. So that is everything. I'm going to go ahead and stop the share. Thank you guys so much for attending.